Hey guys, welcome to Chapter 8. And so today we're just going to be looking at Lesson 8.1. So you should have the notes packet that I gave you guys. So go into that notes packet and flip it to page 218 so that you're looking at the same page that I am. So guys, just like any other day, you're going to fill out these notes just like you would in class. Okay, so this won't be any different. I'm going to go through these a little bit quicker than I normally would in class because you guys, if you ever need to write something or to slow down, you can always just kind of pause video and write down whatever you got to write down. So here we go. So chapter 8 is all about sequences, right? Number sequences. So we're looking for basically an ordered list of numbers. So you could have something as simple as 1, 2, 3, 4. That would be a sequence. We could see some like this where it's like 2, 4, 6, 8. So we're going to get all these different kinds of number patterns. And so the first part of this just kind of starts out with a couple definitions, a couple basic ideas that you guys are seeing in here. Let me slide this down a little for you. All right, so two things real quick. Mostly what we deal with in here is something called a finite sequence. I know you guys have heard the word infinite before, right? You know something that's infinite is something that goes on forever. So when you see the little ... right, that implies that this list just keeps going on forever and ever and ever. But for the most part, what we're going to be dealing with is some kind of a finite sequence. So this is just the opposite of infinite, right? Finite means it does come to an end, right? So as you see in the one right here, this sequence only has 4 terms in it, okay? Whereas this one goes on forever. One of the first things we're going to talk about today is writing a rule for a sequence, right? And a rule looks something like this. If I told you guys to look at this number pattern and just tell me what the pattern is, right, you would probably say, well, we're increasing by 2 every time, right? So it goes from adding 2, then adding 2, then adding 2, and so we would probably describe it as adding 2 every time. But when it comes to writing a rule, it's not just that kind of a description. What we're really seeing on this in terms of a rule is we would look at this and we would identify what term number each one of those belongs to. We would say this is our first term, that's our second term, that's our third term, that's our fourth term, and so n always represents a term number. And then as I look at the values of those terms, the way that we really write a rule is by saying, so what did you do to n in order to get this number? What did I do to 1 to get 2? What did I do to 2 to get 4? What did I do to 3 to get 6? And what we're looking for is a common answer that would fit all of those terms. So if you look at this, you might say, well, I multiplied this by 2 to get him. And I multiplied this by 2 to get this one. And I multiplied this by 2 to get this one. So what we really did is we took our value for n and we multiplied it by 2 in order to get those sequence numbers. And that's what this rule would look like. So we multiplied our n values by 2 in order to get the rule. Here's something that is extremely important for this whole chapter. When you guys see the little a of n and an n, those guys always go hand in hand together. N always represents a term number, like this, whereas a of n always represents the value of that term. So these would represent a of n values. So these are my term numbers, and these are the values of those terms. So let me keep going here for you. So flip that over to this one. And then the last bit of vocab for you guys is a sequence is where you write out a list of numbers separated by a comma. But a series is where you're actually adding all of those terms together. So whenever you have a sequence and you want to find the sum of that sequence, we then call it a series. So a series is just the sum of a sequence. When we write a sum of a sequence, one of the ways, and there's many, but one of the ways we can identify a sum is by taking our values and putting it into something called summation notation. This weird looking E that you see right there is the Greek letter sigma. And sigma always represents a sum whenever we're doing math terms. All right, so whenever we see that symbol, we know that we're finding the sum of a sequence. So here's how this works, and we'll do a couple of these here in a minute. But when you look at this, the value that you see on bottom is the term that you're starting with, and the value that you see on top is the term that you're ending with. So in other words, right now we're going to find the sum of terms 1 through 4. All right, that's these guys. So this is finding the sum of terms 1 through 4. This is term 1, term 2, term 3, term 4. And so we're finding the sum of terms 1 through 4. What you see on the right is the rule of that sequence. And we identified this rule just a second ago. Right? We looked at this and we said, okay, what am I doing to my n value, my term number, in order to get the value of that term? And we said it was always dividing by 2, right? So this was the rule that we were plugging that into. And now this can actually go into, you can solve this either in Desmos, or you can solve it using one of my calculators. And I'll show you that here in just a second. But let's flip over to some problems that we're actually going to go through today. So if you turn the page to this one, we're going to start out with some basics. So when it says find the value of the first 6 terms of the sequence, well, here's the rule. We're going to use the rule to find our numbers. So if I want the first term of the sequence, that just means n is 1. So the way that we would write that is we would say a of 1, which just means the first term, is when I take a value of 1, plug it in for n, since it's term number 1. We're going to raise it to the third and subtract 1. So I'm just plugging in a 1 for n in order to figure out what the first term is. Well, 1 to the third is 1, minus 1 is 0. If I want the second term, then I'm going to plug in a 2 for n. So this now means the second term. And if I plug in a 2 for n, it's going to say 2 to the third minus 1. Well, 2 to the third is 8, minus 1 would be 7. And this could keep going. Let me just do like 1 or 2 more. So if I wanted to find the third term, then I plug in a 3 for n. So 3 to the third minus 1. So 3 to the third would be 27. 27 minus 1 would be 26. And so you could keep doing this. I'm not going to go through all of them, but in the homework, if it does say find the first 6 terms, then you would do it for all 6. Okay, and so you're just going in, plugging in a 1 through 6 for the n value right there. All right, so let's go down to these guys where we have to describe it and write a rule. This is maybe one of the hardest things that we do this whole chapter, to be honest, because sometimes it can be pretty challenging to see what this pattern is or what the rule is that we're going to come up with. So if we were just to describe this out loud, we would probably say, well, I'm adding 2 every time, right? So for the part where it just says describe it, that's like describe it in your own words, right? If I was going to describe this in my own words, we would probably just say, well, I'm adding 2. And so that would be our description. We would just say, I'm adding 2 every time in order to get the next term. But writing the rule is different. Okay, writing the rule is a equation that we would write involving the term number. And so we're going to do that here in just a second. It did say write the next term. So using this pattern, if I'm adding 2, I know the next term in my sequence would be a 5. Right? And you could keep going. You could keep adding 2's to get that. But let's talk about writing the rule, because here's the challenging part. So if we're going to write the rule, your best approach is to just lay it out like this. So these are my term numbers, right? This is my first term, second term, third term, fourth term, fifth term. So the question is what am I doing to n in order to get the a of n value? So what are we doing to 1 to get negative 3? What are we doing to 2 to get negative 1? Right? On and on and on. Now this one's a pretty tough one because it's not just one operation. This one is actually 2 operations. Right? So, and I'll show you this one. The more that you do this, the easier it gets. I after we get past our first lesson, you'll see in the later ones we actually get formulas for some of this, right? And so usually we're going to be using a formula. Today is about kind of figuring it out on your own without a formula, right? So as we look at this, the combination of operations that we're doing here is I am multiplying this by something, and then I am subtracting something. So as I look at this first one, we could say, well, what if I took that 1 and multiplied it by 2 and then subtracted 5? So 1 times 2 is 2, minus 5 would give me negative 3. Let's see if it works for the next one. So if I took my next term number, which is 2, and applied the same rule where I multiply it by 2 and subtract 5, does it give me the second term? So 2 times 2 is 4, minus 5 is negative 1. So it works for him as well. So I'm just going to try it on one more. If I took my third term, so if n was 3, if I multiply that by 2, I get 6, minus 5 is 1. I do get my third term. So you can see here what we're doing is we're taking our values for n, multiplying them by 2, and then subtracting 5. So I'm taking my value for n, multiplying it by 2, and subtracting 5. And so then that would be the rule for this sequence. And we should write that as a of n equals. So that would become the rule for that sequence. That's one of the tougher ones. That's a hard one to do because it has 2 different operations, and that's a hard thing to figure out without a formula, but that's kind of the challenge today. Like I said, moving forward, we're going to get formulas for a lot of this, so it won't be quite as tough. Let's look at one more. So if I go to number 4, guys, anytime you see a fraction, just separate them. Okay, so separate what's going on top from what's going on bottom. So if I was going to write a rule for this, if you look across the bottom, well, obviously the bottom is always 5. So the bottom of the rule is always 5. All I got to figure out is what's the rule for 2, 4, 6, 8. So remember, that's like saying first term, second term, third term, fourth term. And we already saw this one earlier, but I'll just kind of do it again. What are we doing to 1 to get 2? What are you doing to 2 to get 4? 3 to get 6, so on and so on. Well, we're taking our value for n, and we're multiplying it by 2 to get this value. So we're taking our value for n and multiplying it by 2. And so then that would be the rule for this sequence. So let me jump down to number 5. Not too much longer on this one. Okay. I mentioned summation notation earlier. Summation notation is where you have the Greek letter sigma, which looks like this. And on bottom, we're always identifying which term we're starting with. Well, in just about all cases, we're going to start with the first term. And so we're going to say n equals 1. Just to note that, yes, I'm starting with the first term. Sometimes they don't use an n. Sometimes they'll use like an I or a K. It doesn't matter. Okay, it all means the same thing no matter what the letter is. But I'm starting with the first term, and you'll notice on this one, see how this one says ... That means this one is actually going on forever. This is infinite. So the top of this is usually where we would say what term we are ending with. And I'll do that with another one to help you see another example. But in this case, if it's never ending, we would just say, well, this thing goes on forever. It's infinite. So that's what we're starting with. That's what we're ending with. And this is going to be the rule of that sequence. And so we're going to put the rule in for this. This one is extremely tricky because the signs alternate, and there's a whole nother challenge for that. Just so that I can keep this a little more plain for our notes today, I'm going to turn all those into a positive, just so we can try to identify this rule. As you guys look at this, and I'm going to bring it over here so it doesn't interfere with my answer. 1, 4, 9, 16, 25. So here's what we're saying. Remember, this is my first term, second term, third term, fourth term, fifth term. And so the question you got to answer is, what am I doing to n in order to get this value? What did I do to 1 to get 1? What did I do to 2 to get 4? And 3 to get 9? I'll tell you in a sec. If you want to pause and try to figure it out, you can. You might notice on this that we're taking our value for n and we are squaring it. 1 squared is 1. 2 squared is 4. 3 squared is 9, so on and so on. So what we did for this is we took our value for n and we squared it. And so that's what this would look like in sigma notation. So this is saying I'm finding the sums of terms 1 through forever according to this rule. Right? And that's how we would describe it. I'm going to do one last one with you because I'm going to show you this in the calculator. Go back to number 3. Let's just say this was all I had. I had terms 1, 2, 3, 4, 5. I have 5 terms. We already figured out the rule, so this will be pretty easy. But let's see if we can put this, if I wanted to find the sum of those 5 terms, let's see what that would look like in sigma notation. So set up your sigma. And remember, we always start by identifying which term we're starting with and which term we're ending with. We're pretty much always starting with the first term, so I'm going to say n equals 1. I am ending with the 5th term, so we put a 5 on here. So that would tell anybody looking at this, get that out of the way, that we are finding the sum of terms 1 through 5. Right? We're finding the sum of the first 5 terms. In other words, I am adding those together. On this side, we always put the rule. And we already figured out this rule was 2n minus 5. So that's what it looks like. So the sum of the first 5 terms according to that rule. Now I'll show you a quick calculator feature. You can do the Desmos one on your own. Literally, if you go into Desmos and type the word sigma, it'll pop up with a little sigma notation. And you can do this in there. But if you want to use one of mine, it goes something like this. Go into the math button, and you're going to scroll down to the one that says summation and hit enter. And it pulls this up for us. I'm literally going to type in this information. In the calculator, though, we use this button for when we do variables. It's going to use x. It doesn't matter if it's x or n. It's still going to come out the same. So we're going to say our x equals 1. And I'm going to go up. We're ending with term 5. And then I'm going to go to the right. And in those parentheses, I need to put the rule, which is 2n minus 5. So 2x minus 5. And then just hit enter. And that's the sum. So in other words, if you were to take those 5 numbers and add them together, they should add up to 5. So that's the way our sigma notation works. It helps us find the sum of a sequence. Well, that's it, guys. That's it for lesson 1. We'll get into 8.2 next time. So now that you've had a chance to take a look at this and hopefully you took good notes, you can jump into today's assignment.